Welcome to this lesson on cations and positive ions. In this video, we'll explore one of the fundamental concepts in chemistry, understanding atoms that have lost electrons and become positively charged. Cations play a crucial role in many chemical processes, from forming compounds to conducting electricity in solutions. Let's dive in and discover what makes these particles so important in the world of chemistry. A cation is an ion that carries a positive charge. But what exactly does this mean? When an atom loses one or more electrons, it becomes a cation. The key point to remember is that cations have more protons than electrons. Since protons are positively charged and electrons are negatively charged, losing electrons means there are more positive charges than negative charges. This imbalance creates the overall positive charge that defines a cation. Let's look at how cations actually form. We start with a neutral atom, where the number of protons equals the number of electrons, giving it a net charge of 0. When this atom loses one or more electrons, something interesting happens. The number of protons stays the same, but now there are fewer electrons. This means the protons outnumber the electrons, resulting in a net positive charge. This positively charged particle is what we call a cation. Let's examine a real example with sodium. A neutral sodium atom has 11 protons and 11 electrons. When sodium loses one electron, it transforms into a sodium cation, written as sodium plus. Now the sodium cation has 11 protons but only 10 electrons. We can represent this process as sodium atom transforms into sodium plus cation plus 1 free electron. The result is a sodium cation with a +1 charge, because it has one more proton than electrons. Here's something fascinating about cations. They are smaller than their original neutral atoms. Why does this happen? When an atom loses electrons to become a cation, the remaining electrons experience a stronger pull from the nucleus. With fewer electrons to share the attractive force of the protons, each electron is drawn closer to the nucleus. This increased attraction causes the electron cloud to shrink, making the cation smaller in size compared to the neutral atom it came from. Many elements commonly form cations in chemical reactions. Hydrogen plus is the simplest cation, formed when hydrogen loses its single electron. Lithium plus, sodium plus, and potassium plus are alkali metal cations, each formed by losing one electron. Magnesium 2 plus and calcium 2 plus are examples of cations that lose 2 electrons, giving them a +2 charge. Aluminum 3 plus loses 3 electrons, resulting in a +3 charge. These cations are found throughout nature and are essential in many chemical processes. Naming simple metal cations follows a straightforward rule. We simply use the element's name followed by the word ion. For example, sodium plus is called sodium ion. Calcium 2 plus is called calcium ion. Potassium plus is potassium ion, and aluminum 3 plus is aluminum ion. This naming convention makes it easy to identify and communicate about these positively charged particles in chemistry. Cations are incredibly important in chemistry and everyday life. They are essential for electrical conductivity in solutions, which is why electrolyte drinks contain cations like sodium and potassium. Cations form ionic compounds by bonding with negatively charged anions, creating substances like table salt. In biological systems, cations are critical for processes such as nerve signaling and muscle contraction. They also drive countless chemical reactions and bonding processes that are fundamental to chemistry. Understanding cations gives us insight into how matter behaves and interacts at the atomic level.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.